This says 90%.
Yeah, it says 90%, but we're using the 95%.
Right.
Oh, yeah,
Yeah, I'm
okay.
like,
Yeah, yeah.
please, but.
No problem at all.
Good.
So,
Thank you.
Like an idiot.
so it's the, here's the thing.
Well, one point,
It's asking for 90%.
yeah, I have the same
right?
question.
Alright, if we want a, what are we, we're 90% confidence interval. Alright, what are we missing in our 90%? What's your name again, I'm sorry?
Oh, 10%.
Shamika, what are we missing in 90%?
10%.
We're missing 10%.
Right.
Tell me, what do you know about that 10%?
Dividing into it's 5 and 5 on each side.
Yeah, so we could be making 5% chance we could be too high, 5% chance we could be too low.
Right.
So we need to know the appropriate z-value, the number of standard deviations we need to go above the mean that would leave 5% on this side.
Oh,
And we need to know the number of standard deviations we go this way that would leave 5% on this side. Okay, so the easiest way, I think, is to look at the negative side first. Find the z-value associated with 5% of the area on the right side. And what do we find the z, when you look on it, point, no, look at the other, you're looking at the wrong one. Yeah, you're looking at the wrong page. Yeah, you're looking at the wrong page. Yeah, that's the wrong page. That's the positive page. So look at the negative page.
Always?
No, when you're looking for the negative side, you look on the negative page, positive side, look on the positive page. Alright, you can use mine.
The z value,
Yeah.
1.65.
So, oh, you got it? Yes, that's it. Alright, so 5% of the area under the curve would be associated with which? What z value? So look in the middle of the table for 0.05.
1.64.
Yes. And it's negative, right?
Yes.
Yes, so if we go 1.64 standard deviations to the left, we are going to cover all but 5% of the data.
And then 95% will be positive, which is 1.64.
Yeah, and the part that gets confusing is if there's 5% here, there's 95% left. It's tempting to think, well, 90% confidence interval, let's look for 90%. There's 5% here, there's 95% here.
So on the positive side, it's 1.64 as well.
You don't want to score higher on that, on the positive side.
Well, it's identical on the positive and negative side, or the symmetrical opposite, whatever.
What he did was,
Is identical.
he just wrote this in
So it
round.
doesn't.
Because he was looking, that's all.
And Shamika, where it may get a tiny bit confusing is I say go for the more extreme number, so it's between 1.65 and 1.64. I say go all the way to 1.65. And here it's between 1.6, positive 1.65 and 1.65. I say go all the way to 1.65. That just makes it a little bit wider. Alright. So we are at page 290. 290. And this is just one of these things that just takes a lot of time to sink in. I've learned this several times. I learned this as an undergrad, I learned this as a grad student, I learned this when I was working in finance, and I learned this when I had to start teaching it. Every time I'm like, make sure I'm clear on this again. I spent a lot of time just ruminating on it, really. I mean, you don't have to be weird like me, but as you're trying to fall asleep, you think like 5%. As you're working out at the gym, you're like, alright, you got z-score on the negative side, z-score on the other side. Just that mental rehearsal will help you be able to reproduce it when you need to produce it. Alright, so I'm back to page 290. I'm looking at the solution to exercise 8.6. I'm looking at A. So we know the difference, mean difference, 22.3 minus 17.6 is like 4 point something. And Shamika helped us figure out that we want to go plus or minus 1.65 standard errors. And we have the formula for standard errors. So we use the Carlos method and just crunch all that together without identifying the margin of error. And, actually no, actually they do. The margin of error is 1.64. Yep. And so 4.7 plus 1.64, 4.7 minus 1.64. We can be 90% confident that the difference in error rates between 3.06 and 6.34. Now, an important thing to note is that number does not cross 0. Right? It's between 3 and 6.34. 3.06. It's not between -1 and 5. If it were between -1 and 5, it would cross 0, and we could say we can't even be sure that there's any difference at all, because the difference between them could be 0. Does that make sense?
Which would mean what,
Would there
that
be
your
a problem?
information is right and there's no.
It means we have no reason to say that there's any difference between the error rates. We can't be confident that there's any difference between them. The difference between them could be 0.
So would there actually be problems like that, where you actually get a negative when you cross a 0?
And then
So then you would just say like, it's inconclusive?
you could say it's inconclusive whether there's any difference between them. You could also still give me a confidence interval. It would include a negative number on the lower side and a positive number on the positive side.
Where did we get 1.64 when we started?
Yeah, we multiplied 1.65 times that square root
And
chunk.
that- and that's what we
Yeah, and it just happened to be one, that's kind of annoying, right? It just happened to be 1.64.
Yeah, that's if I see the 2, I'm like,
That's the margin of error.
Yep, that is the margin of error.
I'm not.
Okay, alright, let's do number 32 on this page. This is a good one. Take a look at number 32, try to work through that. And we'll come back together in about 4 minutes.
A little longer.
Time out.
What's this? You're at 172.
Oh, it's not that then that's the sum. That's the same.
This is what you You're the worst.
And two.
I'll use the new signal.
Oh, 67.
You wrote everything that you put on the course.
That's just what I did. I looked up and I saw it. You're right. You're right. When you want to set up, you do.
I can see it, this is right. It might not be. Yeah.
You couldn't figure it out.
Did you get free standard or? Yes. 138. Yeah. Yeah, Drew, did you finish?
I'm not sure, I should have asked that.
I got 139.
That's on the same.
What, 120?
Eight, you're up for eight. No, we're gonna be honest.
Alright, we ready to start? Let's do it. So this is a survey of Scottish workers trying to figure out the average salary among men and the average salary among women. And they were trying to find out what the difference was. They might have been trying to find out if they could conclusively say that there was in fact a difference. So they took a sample of 1,500 men, 1,200 women. The average salary among men was $317. Average salary among women was 172 pounds per week. What is their point estimate for the difference between men and women salary per week?
145.
Yes, that sounds right. All right. Switch hands here. 145. All right. Now, so do we just stop there and say that's the difference?
No.
All right. We need to find out the standard error. The great thing about the standard error is once we find that out, we know that it's normally, the sampling distribution and sample mean difference is normally distributed. So we know exactly how many standard errors we need to add to and subtract from the point estimate to get our desired confidence level. Our desired confidence level is what, 95?
95.
95? All right, so what's the z value we need?
1.96.
1.96 plus minus. All right, now let's do the standard error. So we take, this is 89 squared, right? 89 squared over 1,050 plus the sample standard deviation of women's salary, 67 squared divided by 1,200. The square root of that whole thing
3.
is 3? That's it? Okay. 3?
But I came up with 3.
We get, who else?
3.003.
3.00 what?
3.
3.5, okay, 3, fantastic. Alrighty, so we need 1.96 of those in order to be 95% confident. So let's take our point estimate, 145 plus or minus 1.96 times 3.0035. Alright, and we call this, just to keep things straight, our margin of error. What do we get there? 5.8868. Alright, that has kind of a nice 8 quality to it. Alright, so 145 plus or minus about 9. No, plus or minus about 6. So that's going to give us a lower level confidence interval and an upper level confidence interval. What do we get on the lower end?
139.11.
0.11, and on the upper end?
150.89.
0.89. Okay, so we were tasked with finding the average difference in salary between men and women on a weekly basis. We took a sample and we found our point estimate to be 145. And we can now say that we are 95% confident that the true difference in salary between men and women in Scotland in this category is between 139 and 151 pounds per week. Pretty big difference, right? Yeah, I mean, maybe when we looked at the 145 and said, oh, that's just a sample. Who knows? There could be a big margin of error there. But we found a relatively small margin of error. And we could say with 95% confidence that this is what the true difference is. And we could still have a pretty significant answer if we wanted to go further out. If we wanted to go like 99% confident. Do you want to do that? Just for fun. All we need to change for 99% confident is we change the z value. And I think it's 2.58 or something. 99% confidence would be 0.005 on the lower end.
98% confidence, is that?
999. Yeah, 2.58. So we would just need a little bit wider of a margin, and we could say we're 99% confident that this very significant difference exists. Yeah, this could be powerful. We could be 99% confident that a very significant difference exists between these two populations in terms of mean income.
And that's a difference.
Yeah. This is if we're just at 95%, we say we're 95% confident that the true difference between these two populations is 139.11, and between 139.11 and 150 point.
So you're relaxed.
And that's the difference in salary, right?
Yes, like weekly salary, right? Is it weekly salary?
Yeah, average weekly salary.
It's pretty huge, isn't it? Weekly salary. Right. Let's leave that right in the middle of our slides.
And there's more.
And we're ready to move on to the last section?
Yes.
Yes.
All right. So what if we want to do proportion differences? What if we say the proportion of men who support Donald Trump is, we think, 49. We think the proportion of women who support Donald Trump is 41. Well, if we want to find the difference between those, that would be 49 minus 41 would be 8%. Maybe we took a sample and we found an 8% difference. 8% more men support Donald Trump than women who support Donald Trump. We need to find the confidence interval associated with that. Now, as I mentioned with the mean differences, we already have some skills to do this, right? Like what did we learn at the beginning of class? We learned how to calculate a proportion and take a confidence interval for that proportion. So we could do our confidence interval for men who support Donald Trump, confidence interval for women who support Donald Trump, and we've got some approximation of the difference. Now it's just a matter of how do we combine those two. And in a similar fashion that statisticians gave us a formula to combine mean differences, they give us a formula to combine proportion differences. Alright, so if we were to take proportion differences, sample a bunch of men who support Donald Trump, sample a bunch of women who support Donald Trump, let's find the difference. Alright, let's make a note of that. Let's do it again. A bunch of men, a bunch of women, do it again. Let's do that 10,000 times, put them on a frequency distribution. What does the distribution look like? And we're going to call it sampling distribution of the sample proportion difference, probability distribution of all values, all possible values of sample proportion difference, P1 minus P2, so proportion 1 minus proportion 2 is the difference. And sample size from one population, sample size from another population. Alright, remember this pi symbol, that's the population proportion. The P bar 1, P bar 2, that's our sample proportion. Okay, the difference between the two proportions in reality, populations, is pi 1 minus, population proportion 1 minus population proportion 2. And we're going to get a point estimate with our sample proportions. The shape of this distribution is going to be normal if we have a large enough sample size. And we're going to go back to this n times p bar greater than or equal to 5 concept that we talked about earlier. So the closer the proportion is to 50%, the smaller the sample size needs to be. If it's, say, 1%, then again, we need to talk to 100 people before we even expect one person to say yes. So we want to talk to at least 500 people. The mean of this sampling distribution of proportion differences is going to be the true population proportion difference. So of course, we would expect to hit it right on most frequently. Sometimes a little high, sometimes a little low. And there's going to be a standard deviation of this sampling distribution of the sample proportion differences. And it should look familiar. This is just some version of the standard deviation of proportion differences for one population, for another population. Add them together, take the square root. Yes, John?
Zach, we did sample proportions before, and now we're doing population proportions?
Okay, so the first thing we did was sampling distribution of sample proportions.
Sampling distribution of sample proportions,
Yeah, and then we did something in between that, which I won't say.
okay.
But now we're doing sampling distribution of sample proportion differences.
Okay.
So the first thing we did tonight was sampling distribution of sample proportions. Third thing we're doing tonight is sampling distribution of sample proportion differences. It's just the differences added on at the end.
Can you just say difference between the two population?
Yeah, that's what we're talking about. All right, this is going to come out to a beautiful normal distribution. The mean of this distribution is going to be the same as the difference of the two populations. The standard deviation is going to be this figure. And of course, it's going to have all those great predictable qualities. We're going to take a sample, and we're going to know that we have a 95.5% chance of being within 2 standard deviations of the center. We have a 68.3% chance of being within 1 standard deviation of the center. that to create confidence intervals. So this P bar 1 minus P bar 2, that's our sample proportion. So 49% men said they like Donald Trump, 41% women said they like Donald Trump, 49 minus 41 is 8. So that would be our point estimate for the difference. Plus or minus some number of standard errors. How many standard errors? Base that on our Z. How confident we want to be. We asked Donald Trump, how confident do you need to be about this? And he's like, yeah, 68.3, that sounds a little high. Maybe 20% confident. Alright, so if we do not know the population proportions, we use our sample proportions, fill those in. We can stay with Z, because if you recall, this standard deviation was based on the math of how close this proportion was to 50%. So statisticians are comfortable with using the Z distribution for that. All right, wanna try an exercise?
Yeah.
296, 8.8. Okay, here we go. So we've got a survey. Actually, let's do it this way. Why don't we have you all work on this silently, or not silently, you can talk to your neighbor for a minute. And then cover up the solution, like put your hand or something over A, B, and just try to think about how you would crank this out. And I'll put some of the numbers up on the board, and we'll work this one out as if we didn't even have that answer. And then when you're confused about what happened in class tonight, you can come right back to this and say, oh, that was the answer right there. So just see if you can work this one out on paper, work it out on the board in a minute, and we'll compare that to the answer.
Can you come here for a second?
Yes.
Why for this example, they didn't multiply the C value and
Oh, here, go back to that. Okay, so this times 1.65 just so happens to be
right, that's why I know.
1.64.
That was very close.
Yeah. It just so happens that 1.65 times that is 1.64.
So they didn't multiply the standard error?
Yeah, this is the standard error right here. See, this all under the square root, that's the standard error.
Okay. Because I know for all of your examples, you don't multiply these two, and it'll be this plus and minus. And then I started here too, so I was confused. Okay.
I'll be in the negative, right?
Oh,
You want to use that?
What?
Is this something completely new?
Yeah, that's completely. Yeah.
I love how easy it is.
You have to like calculate.
That's where, that's where he's going.
You still got it right though. You still got it right.
Alright, so we're ready to try this one?
How many is that?
Alright, I will guide you. So, this one interviewed flight attendants and asked them what was the reason why you joined or became a flight attendant. And there are two populations. There's a population of senior flight attendants, older, and a population of junior flight attendants, younger. And they asked them, both groups, the same question. What factor was most significant in you choosing to become a flight attendant? And 35% of the senior flight attendants said opportunity to travel, or a certain number of senior flight attendants said opportunity to travel, a certain number of junior flight attendants said opportunity to travel. Let's get those percentages before we talk further. So, out of the 100 senior flight attendants, 35 said opportunity to travel was the key reason they joined and became a flight attendant. So what percentage of senior flight attendants had opportunity to travel as the main reason? 0.35. Alright, 40 out of the 150 junior flight attendants they asked said opportunity to travel was the key reason they joined. What percentage of junior flight attendants? 0.4, so 40%. Alright, so let's get,
That's over 150, not 100.
Over 150.
yeah, that's right, that's right. It's not 40.
Oh, it's 111.
Yep, alright. Yep, it is 0.27?
Yes.
Okay, so, let's get our point estimate for difference. Alright, what's the difference in these two populations? Senior flight attendants versus junior flight attendants. So the senior flight attendants, 35% said opportunity to travel was the key reason. 27% of the junior flight attendants said opportunity to travel. So this is 0.35 minus 0.27 equals 0.08. Alright, so there's an 8% difference. Talk to me about that. An 8% difference of what?
8% difference of reasons why
But there's one specific reason why they joined. So 8% more of 8% more of the senior flight attendants said opportunity to travel was the key reason. So we might be looking at this and we might say, oh, the older flight attendants, they were really keen on travel. The younger flight attendants, they wanted the money. Exactly. So that is our point estimate for the difference between these two populations. Now we don't stop there because we need a confidence interval. This is just a sample. We know it's going to be reasonably close. In fact, we know the percentage-wise how close it might be. So let's construct that confidence interval to find the true difference for the whole population of senior flight attendants versus the whole population of junior flight attendants. What it is, or what it could be. So let's do our z-value first. How many standard errors do we need to go plus or minus of this 8% to be, what do we ask for, 95% confident? 90. Okay, so what's the z-value we need?
1.65.
1.65 plus minus. Alright, now, the standard deviation of the sampling distribution of sample proportion differences, senior, junior, okay, is, what? We do the proportion of seniors, 0.35 times 1 minus 0.35, divided by the number of senior flight attendants we asked,
100.
which is 100. We're going to plus 0.27 times 1 minus 0.27, which is 0.73. divided by the number of junior flight attendants we have, 150. We square root that whole thing, and we come up with what? Does it tell us in the book? Just give us the answer to that. What's the standard error?
I got .059.
So-
The book says .06. So I mean, it's pretty close.
Yeah, okay, good. Yeah, that's fine.
But then for the margin of error, I got .97. We got,
.097?
They got point.
hold on. Yeah, I got .097.
I got
Okay.
.0599.
For what? For this?
Would it be, would
Ac-
that, would
Yeah,
we
you got
round it up to
.095,
60?
.059?
Will we round it off to 60?
Yes. I mean, you keep it in your calculator till you're getting to the final answer, but just for purposes of our discussion, as long as you're close to this, we're on the right track. What we do next is we take our point estimate of 8%, and we need to add some margin of error, subtract our margin of error, and so let's do that. 0.08 plus minus 1.65 times 0.059. All right, let's calculate this out, this margin of error, just to keep it straight in our head. What do we get for this margin of error?
.0988.
Okay, 0.0988. Okay, what percentage is that?
99.
That's like close to 10%.
Yeah.
And what's our point estimate for the difference? 8%. So the margin of error is bigger than the point estimate for the difference. So, yeah, so where do you think we're going with this?
Gonna get negative.
We're gonna get a negative, which means it's possible not only do, it's possible not only to do a smaller number of, it's possible that either the junior flight attendants or the senior flight attendants could have a higher preference for travel. Our point estimate came up with the older flight attendants value travel more. Our confidence interval is going to force us to say, well, maybe the older flight attendants value travel more, or maybe the younger flight attendants value travel more. We're not going to be able to conclusively say which one values it more at the 90% confidence level. All right, so let's put these numbers in. What's our lower bound for confidence?
Negative .01.
All right, and what's our upper bound for confidence? Oh, yeah, 179. All right. All right, so this is a lower bound of, let's put this in percent, of negative 1.9%. Upper bound of 17.9%. Okay, so how do we interpret that confidence interval?
This is times.
That may not be
We could say it a number of ways. We could say our estimate for the population difference, older flight attendants versus younger flight attendants, is between, we're 90% confident, negative 1.9, which means the junior flight attendants are 1.9% higher, and 17.9%. So let's just, like, if these numbers were different, let's do an easy one first. If you say these numbers were 2% and 19%, suppose that's what they came out to. How would we verbalize that? It's going to start here. Yeah, go ahead.
Go ahead, John. We're 90% sure that it's 90.
Between
difference
2%
between-
and 19% of the junior and senior flight attendants value travel more.
Right, you got,
Between 2 and 19%?
Okay, we're 90% confident that the difference between senior flight attendants and junior flight attendants and their desire for travel is the most important factor is between 2% and 19%. So it could be as low as 2%, could be as high as 19%. Could be as low as 2%.
No, the whole thing. We are 90%.
I was afraid that's what you were asking.
We are
90% confident.
We're 90% confident that the difference,
Between junior and senior.
somebody help me out here.
The difference
We're 90%
between
confident the
senior
difference
flight
between
attendants is between 2% and
Value
19%.
senior and junior.
Yeah, that's good, except we just need to throw in terms of their preference of travel
Travel.
somewhere in that.
Prefer to travel between 2 and 2%.
So we are 90% confident that the difference between,
We're 90%
Junior,
confident.
senior and junior is between 2% and 19%.
Yeah, we're 90% confident that the difference in preference for travel is the most important factor between senior and junior flight attendants is between 2% and 19%. In either case, senior flight attendants value it more. Senior value it more. Now this is if these numbers came out this way. If these numbers didn't come out this way, the lower bound was a negative. And the negative would mean that it's not that senior flight attendants value travel more, it's that junior flight attendants value travel more by almost 2%. So the lower bound is junior flight attendants value travel more by 2%. The upper bound is that senior flight attendants value travel by 18% more.
You'll see it, you look like you're waiting for the fireworks.
Could they buy that?
Yeah, really?
Did they
Let
find
me
that?
just tell them something along the way.
Why is the lower bound the junior? How do you know which end value and one and two?
Yeah, we said sample proportion senior minus sample proportion junior.
No, this is the lower
So
level.
the seniors are N one, or
Yep.
population?
In senior, in junior.
Sample one.
Yeah,
It's,
so
Minus
if this is a negative number, that means the junior proportion, the junior preference is bigger. Well, that's a good point. So Barbara asked me, how do I know that it's junior or senior? Because when I started this equation, I started it as sample proportion of senior minus sample proportion of junior. So if the senior preference is greater, then that's going to give me a positive number.
Oh, yeah.
But if the senior preference is less, then it's going to be a negative number. So that's what this negative number is the senior preference is 2% less. This is like, whatever, this is like 8 and this is 10. So subtract 10 from 8 and I get negative 2.
I'm just, how do you phrase this thing? I'm sorry. That's all I.
Okay.
You,
So-
you don't need to.
We're 90% confident.
Sorry.
Okay.
Yes.
Yeah, or between, actually, you know what?
Oh, negative.
You know what? I've got an idea here.
Okay.
I knew this would come in handy. You know what we did is we actually did a sample. Are they gonna tell us how to say this? No. Characteristic interest. Oh, it doesn't say. Alright,
It says
so,
it in the note, no?
wait a minute.
Says the negative lower bound indicates.
Alright, we're 90% confident that the difference in proportion between senior and junior flight attendants and their preference for travel is between negative 1.9 and 17.9%.
So we can't say negative 1.9.
Yeah,
Oh,
yeah,
I had that like 5 minutes ago.
good. so.
I thought you were saying we had to say something else.
No.
No.
All I'm trying to say is, what does it mean when you say a negative number?
It means that they are two.
So on the quiz, it's gonna be that simple.
Oh,
And you'll just put the confidence interval.
Okay, that's it. So,
And I think for the quiz, there's just one of each. There's one proportion confidence interval, there's one mean difference confidence interval, and there's one proportion difference.
only 3 questions.
I think so.
How many questions?
I think there's only 3 questions.
So one proportion, one mean.
One proportion, one mean difference,
Are
and
we
one
gonna,
proportion.
are you giving us the sample proportion? Or do we need to, is it gonna be a question like this where we have to determine the percentage, the sample?
Yeah, you'll have to determine. It'll be like,
35% of 100.
35% of pro golfers say they like this, 27% of amateur golfers say they like this. What's the
These two.
Are there any words that are gonna give us hints as to which one we're applying?
It'll be pretty obvious. It'll be,
That, think like us, think like us. To you it's pretty obvious.
You should write like building a confidence, using building a confidence. What did we learn tonight?
well, you learn 3 things. You learn proportions. So we'll say, what's the confidence interval for the true population proportion?
Okay.
You also learn mean differences. So we'll say, what's the confidence interval for the difference between two populations? The mean,
Say population.
or average, mean would be an average, I would have an average in there. And proportion difference, it'll say 2 population proportion, it'll be like, it'll be, 70% of NYU grads say this, 45% of Columbia grads say this. What's the confidence interval for the difference? And yeah, I don't think you'll have any problems knowing which is which. It's just a matter of getting fluent with your calculator, figuring out a strategy, how you're gonna keep everything straight in your head and lay it out.
So we need more than an hour for the quiz.
Do you? Do you need more time for the quiz? No?
The answer, should we actually write like CI equals and then the range in brackets?
Yeah, you can do that, or you can just write, you can write the numbers in brackets. Or you can say lower bound is negative 1.9, upper bound is 17.9.
Can you make it 90 minutes?
Nah.
I mean, just.
I mean, if you finish at 20, then you finish at 20.
Yeah.
I guess it keeps
the thought of
the,
the clock ticking.
This, I feel like
Brain
this is
working
gonna take.
quicker.
So you could do 90 minutes, and anybody who finishes in 60 gets an extra
That's
point.
amazing.
And that would be very fair.
I can't do that, I could do extra time, I guess the only disadvantage is,
What happens when it runs out of time?
is that it's,
Oh,
we wanna keep that, I wanna
Yes.
just keep integrity to the curve, I guess.
Yeah.
Because as we've
We
talked
started
about,
at 60.
as we talked about, the quizzes are the hardest things you're going to encounter in this class. And I
The
feel
final.
fielded a number of questions where people are all scared that they made a couple silly mistakes. I say, please don't worry about that, because everyone makes silly mistakes, and I'm gonna take that into account. If you still have that grade at the end of this quarter, which you won't, because you're gonna turn in all the Excel exercises for 100%, and the final is exactly like all the quiz questions.
Okay.
How much time is on the final? The final is 15.
Finals 2.5 hours,
Oh, man.
same question.
Wait, how much?
Questions.
That's
Yeah,
fair.
2.5 hours.
Final?
10 questions.
How many questions?
Yes.
10. So, can we go over that multiple choice?
Yes.
Okay.
Alright, so we're gonna stay and go over the multiple choice, if you'd like to go over that,
Yes.
otherwise.
hear this, yeah.
Yeah, we got choice. So you guys are exact.
Oh, yeah, that one, man.
Yes,
Number one.
yes.
Two and a half hours, that's really.
Yes, this is the voice stuff. This is the multiple choice.
Okay, nice.
That's my goal.
I like the way you think.
The whole time, you know, you're 90% confident that it's gonna go, start regardless to 5. That way you know.
Yeah, and is the final gonna be on Excel? Or handwritten? Is the final gonna be a handwritten final or Excel?
online, same thing.
Okay, good. 'Cause I've been doing everything on Excel.
Me too. So this is when I'm in class, he knows, that's why he said, Melanie, you do it, and it's, I'm spastic with the calculator, but on the Excel, it's so easy.
Alright, first of all, I write like a 4-year-old, so if I tried to write everything and use a calculator, I'd get lost.
No, see, I do everything by hand. I need to see it, and I go through step by step by
Probably be
step.
better for me that way, but like I said, I've been losing everything because I write through a lot.
No, I just take it.
You went to high school, what the hell?
Yeah,
I was
really.
Catholic high school when they weren't allowed to hit me. okay?
I went when they hit.
They weren't allowed to
I went when
hit
they
me.
hit. You're funny, Brian.
Yeah, finance people use stats all the time.
I do, so I'm gonna jump over this.
Not this class. But hold on, it's like, I mean, I have to just let it soak in.
Here's my theory. Really? This is what I'm trying to say. You guys are trying to understand.
I
No,
definitely encourage
It's a
that.
problem that I have.
no, for this class, if you want to pass, no, just go. Stay. Match. This is all I'm making. Match check. If he did one, it's what you know, me and so then I'm doing quick. Is this the same one as that? Oh, it stays here. That's what X goes here, and this goes here, and then you make sure you're done. Do not try to finish it unless you do research.
No.
Trust it.
Yeah, you guys can do that.
I'll do that.
Oh, yeah, we don't have that.
Have a good night.
Alright, let me,
You tell me the
And
time.
the one day, you on class, right? You have a Monday class?
Yeah, I did. You see it? Let me show you. Let me show you. Let me show you. Yeah, but yours was, yeah, 'cause-
Thank you guys.
yeah, it's just the guy. Oh, yeah. You got it.
they said, they said 35 out of 100 senior credit, and they said 40 out of 150 junior credit.
Let's do all these questions.
Even though that, I mean, they want you to find.
Struggle. Right there.
Yeah,
But we did well.
These percentages,
yeah, P-bar is sample percentage, sample
Nah,
proportion.
there's my copy, yeah, but it's in there. You can go to the blackboard.
Yeah,
download it.
so proportion, it's, we can write it as a proportion or we can write it as a percent.
Yeah, so this way you
So
got.
proportion like 1 out of 5 would be
Good night, Dina.
or would be a proportion.
That's, this is what I did.
How much
Then I
much leeway do we have?
no, that's what, for the next time, I'll do, you have to read it and come back and take it. You gotta make sure you have an introduction.
You're fine, because mine started.
Because I actually, so I will read only 8 and 17.7.
For an introduction.
That looks good to me.
That's like, I mean, it's not that bad, but.
Well, I mean, keep it, you're doing this. So,
Okay,
okay, so
so
you're-
I know there's 2% left. One on each
So,
side.
I mean, keep it in your calculator as close as you can, and
You guys want, I'll do the whole thing.
for percentages, I
Think
can't see
about
that.
Did you just hear her?
Percentages, I'm good at 4 out of
She's
10.
covering her. Oh, so you did what I
And
did.
it's 38.3, and then 95.5.
Yeah.
That's what I wanted to have.
But it doesn't apply here.
With me, it's actually knowing what
Yeah,
needs
I
to
tried, I think you
instead
did
of
it.
creating like standard average.
You, yours and Nicole on the
You too, thank you.
Mine was actually about
Right,
two.
so I got it like this. Under the curve, there's 100. If they ask me for 98, I'm gonna divide that.
I do have that.
Yeah.
Oh, because I'm not, you're not counting the first cover page.
Oh, got it.
Yeah, those are 2 pages.
Yeah, I got your shirt still chilling in my house.
This is what I did.
Folded up in a bag. Yeah, it's actually, I forget. I gotta take it to work. Oh, I got you. I got your shirt.
I guess I'm gonna.
Good job. It's my turn to do whatever, or we need to talk. I'm sorry.
That's exactly how I feel.
Hi, Gabriel, you okay?
I'll be okay. Yeah, after a couple of drinks.
Oh, okay.
Coconut rum tonight, I'll be good.
There you go.
So you're looking for
Yeah, range, yeah.
5.5%, so that's
You can use two functions in the same cell.
So you use like the, was it the RT one,
Not
the
the
river
master.
one?
Yeah.
I am the plugin master.
You
I
feel
like
like I
this
would
one,
do
this
this
is
well.
this deal. It depends on what you're doing, but, sometimes you can say equals, T distribution right scale,
That's what I was
Right,
thinking.
good, no, and
and
No, I
then you put in,
did the next one. God bless you.
Excuse me. That's what I told you. I'm not, I can't, to spit that into the same is not gonna happen. I can look at it,
okay,
and
so
you plug in.
multiple choice now?
oh, alright, well,
You forgot us.
no, I didn't forget you,
Oh, he's a.
Oh, I'm so
Omar,
sorry.
Omar saw you that you were distracted and he seized the opportunity.
Okay, that's fair.
I need you to do something.
So,
What you
so
need
you
me to
do
do?
X, whatever it is, 3.2.
You slow? These are
and
beautiful.
degrees of
We're getting
freedom,
an A.
120.
I hope so, I don't know, I'm not an expert.
And then you go minus
He's done, he did it.
T, and you can do it again,
Oh, you see it?
right?
Oh, that's yours.
The same thing again in the
So
same.
this is what you just said, he
Yeah,
has
and you're
to spend
finding the
time.
difference.
I know, that's
Like,
true.
The abstract, which is the
It
introduction.
takes,
Who
yeah,
did
it
the
takes
first
time.
question?
He did everything.
Oh, he did the
Each
whole
one of
thing?
us has a case study.
Oh my God, but did he copy mine?
This is favorite.
Wait, that's mine.
Say a percentage.
I did.
That's mine.
What's yours?
I
Percentage.
swear to fucking God.
What's yours?
That's some of what I wrote, right?
Well, everybody's gonna write pretty much the
Okay,
same.
good, so keep going.